Hello everybody. Today we are going to learn about trigonometric ratios. We know from back in 7th grade that if we have these two triangles here and they are similar, and we know they're similar because their angles are the same, they both have x and y and a 90-degree angle. So if two triangles are similar, so triangle ABC is similar to triangle DEF, then their corresponding sides, if we make a ratio here, like this distance over this distance, it's going to equal this distance over this distance. So as long as the two triangles are similar, no matter how big or how small or how much they differ in size, as long as they're similar, the ratios of their sides are always going to be the same. So notice in this case 3/4 is going to equal 6/8. And 3/5 is going to equal 6/10, or 4/5 is going to equal 8/10. So no matter the size of these two triangles, the ratios of the corresponding sides will always be equal. And because these ratios are the same, we have named them. So given this right triangle here, if we're talking about angle A, for instance, then the side, the leg closest to angle A, or the one touching angle A, we call the leg that is adjacent to angle A. And this blue one here, this leg, we would call the leg opposite of angle A, and the hypotenuse, which is always opposite the right angle, which is here in this case, this is the hypotenuse. So if you're talking about angle A, adjacent, opposite, and hypotenuse. And so the ratios, since they're always the same no matter how big or how small the triangle is, as long as we know what this angle is, the ratio of the opposite to the hypotenuse, so the blue over the red, is always going to be the same. We call that sine. So the sine of angle A is always going to be the ratio of the opposite over the hypotenuse. And the cosine of angle A is defined as the ratio of this distance, the adjacent leg, divided by the hypotenuse. The tangent of angle A is the ratio of the distance of the opposite leg and the adjacent leg. Okay? And given a specific angle, these will always be the same. And so what we can do, given if we know the length of these two, or any of the two distances of the triangle, we can figure out the measurement of the angle. Or given the angle measure and one distance of a right triangle, we can figure out another distance or the other angle. So given two pieces of information, an angle measure or a distance, we can figure out everything else. And the way we remember these ratios, so like opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent, is this mnemonic over here. So the first letter stands for the definition, the name here, sine, S, cosine, C, tangent, T, and then O stands for opposite, H stands for hypotenuse, A stands for adjacent. So is the sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So we're going to look at some examples and see how we can use it. So don't be too confused yet. So given this triangle here, if it has sides measuring 9, 12, and 15, we'll just go with the straight definition before we get into how to figure out the angle and whatnot. So sine A is so opposite over hypotenuse. So in this case, the opposite leg to A would be 12, and the hypotenuse would be 15. So sine of angle A is 4/5. Cosine angle A, that's ca, so A over H, so adjacent over hypotenuse. The adjacent leg to angle A is 9, and the hypotenuse is 15. And so that would be, what, 3/5. And then the tangent to angle A, that's TOA, that's opposite over adjacent. So that would be, the opposite would be 12, and the adjacent would be 9. So this would be 4/3. Okay, so some basic questions that you're going to get are like, what is sine 55 degrees? So what you can do there is, depending on the type of calculator, here's a calculator here. I think this one will want me to type in 55 and sine. And so the simple answer is that sine 55 degrees is 0.819 blah, blah, blah. So let's just round to the nearest hundredths here. So 0.82. So the simple answer is it equals 0.82. For tangent 45 degrees, we just plug in 45, hit the tan button, and it says 1. So tangent 45 degrees is 1. And finally, if we want the cosine of 15 degrees, we just type in 15, hit cosine, and it's 0.97. 0.97. So what do these actually mean? These are the simple answers, but what does it mean? Well, what it means is if we add this triangle here, and it's the right triangle, and if this was 55 degrees, we know, we know that the opposite over the hypotenuse is equal to 0.82, which kind of means 0.82 over 1. So we know that if this angle is 52 degrees, that if the opposite was 0.82 whatever inches or something, that the hypotenuse would be 1 inch. And that's, it's a fraction that can be, you can multiply it by something. So like if you multiply by 2, 1.64 over 2. So if this was 1.64, then this would be 2. Okay, so this sine 55 tells us what ratio these sides are in. Tan 45 degrees, why does it equal 1? Well, a 45 degree angle, let me see if I can find one here. Here we go. So if we have a triangle that has a 45 degree angle, you may or may not know this, but if these are both 45 degrees, then these are the same. So like if this is 5, then this is also 5. And so the tangent of a 45 degree, which is TOA, so the opposite over adjacent, so let's say we're looking at this angle here, the opposite 5 over the adjacent 5 is always going to equal 1. So tangent of tangent of a 45 degree angle is always going to be 1. And so for cosine, same thing. It's the ratio of the opposite over hypotenuse. Wait, cosine. So adjacent, sorry, over hypotenuse is always going to be 0.97. An example that shows kind of the usefulness of this here. So let's say we have a right triangle. We know it's right. That's a right triangle. And we know one of the angle measures, and we know one of the sides, but we need to know the measure of this side. Okay. So of this angle, this is the opposite. So we know the opposite, and we know the hypotenuse. So that would be which is sine. So we know the sine of this 48 degree angle is going to equal the opposite, which in this case we don't know, so x, over the hypotenuse, which we do know is 14. So once we get our trusty calculator out, we know that sine of 48 degrees, so 48 sine is we'll just round to the nearest hundredth again, is 0.74. So get rid of that. So we know that 0.74 is equal to x over 14. Now we can solve for x by multiplying both sides by 14. And we get, x equals whatever 0.74 times 14 is. So let's bring out the calculator. 0.74 times 14. And so we know the side of the length of this side labeled x is 10.40 units, inches, feet, or whatever. So here's another example of use of the trigonometric ratios. So here, let's say we know the distance of this line segment, and we know the distance of this side of the triangle, and we want to know what this angle measure is. What we can do is we know, so this is the adjacent and this is the hypotenuse, so we know adjacent and hypotenuse, so that would be ka, so cosine of angle A is going to equal the adjacent over the hypotenuse, which we know both. We know adjacent is 12, hypotenuse is 24, so we know that is 1 over 2. Since we're using a calculator, we'll say that is 0.5. And so the calculator has this cool button called the inverse cosine, and so the measure of angle A, which often we just say M angle A, is going to be equal to the inverse of the cosine, and it's written like that, and of 0.5. So we know if the ratio of the adjacent over hypotenuse is 0.5, we can figure out the measure of the angle. So let's get to our trusty calculator, and let's clear it out. So we know 0.5, and we want the inverse cosine, so see where that cosine was, there's always a second button. Now we know inverse cosine of 0.5 is 59.99999, so that is 60 degrees. Let's get rid of that. So we know measure of angle A equals 60 degrees. So that is your intro to trigonometric ratios of sine, cosine, and tangent. You're going to learn a lot more about this in high school. This is kind of an intro lesson, and it should be fun kind of figuring out the information about the right triangles. Thanks for watching.